This section 7.3 is kind of a little bit hard, it seems. Okay, so we are solving this differential equation. Now the right-hand side term, I mean, physically, there are physical phenomena look like this. Maybe this RC circuit and others, something similar. But basically this external driving force, okay, this external driving force here, it's not at the beginning. At the beginning, there's nothing driving it. The input is 0. At time t equal to pi, then you start to drive it with a sinusoid. Is it kind of okay?
Yeah.
Okay. So you can think of this as, I mean, I'm going to not go into the detail, but I mean, you can have, I don't know how many of you are in 2 circuits stuff. There's some capacitor, some resistor, have this guy, and there's a switch here. Okay. So at the beginning, this switch is not on. Okay, this is off, this is 0. I mean, you have some charge in the capacitor, you have a resistor, the capacitor is being discharged, and suddenly you turn this, you flip this switch and connect this guy. Once you connect this guy, you're going to have a wave. You have AC voltage here. Okay, this is an AC voltage. So you at the beginning you're not connected to the AC source, and suddenly later on you get connected to the voltage source. Okay, and then you end up with something equations like this. Okay, I don't know how many of you are in circuits.
That was a good example. Thanks.
Okay, so I'm going to erase this because I don't understand this stuff very well. I don't want you to ask me too many questions about this. Okay, but this is the type of situation that will lead to this type of equation. So basically, what is this? This is, I'm going to write this. I'm writing this in another form. In one compact form. This will be cosine 3t times what? Now the cosine 3t, we have to zero out the cosine 3t at the beginning. That means you multiply this by t minus what?
I.
So do you guys need me to explain this more? Because we did a bunch of this, that is the reason we did those. It's this guy, you want to zero out the beginning. This guy, ut minus pi is this function here, right? And this is pi, this is a pi. At the beginning is 0, later on is 1. When you multiply it together with this, it will kill the function at the beginning, and the next part will follow this 3 cosine t. Is it okay?
Yeah.
Yep.
Okay, so this is the function we have, and then we are going to solve this using Laplace transform. Okay, if you don't use Laplace transform to solve this, it's going to be really ugly, because at the beginning you have to solve this problem, okay, with this initial condition, and then see what happened at t equal to pi. That will be the final condition at the time t equal to pi, and then you take that state as the initial condition for the next problem, and then solve the problem again. That can be done, but it's multiple steps, and here we can do it in one step. So we are going to draw this picture. Yt, y s, y prime t. This will be, what will be this here? You guys tell me. Differentiation over here correspond to what? Differentiation in the time domain is the same as
S times y of s minus y of 0.
Minus y0, which is 5. Okay. So we have this guy minus 5 plus what? Plus ys. Now equal to the Laplace transform of this guy, the Laplace transform of this guy. Okay, let's do the Laplace transform of that guy using this formula here. Okay, using this formula here. So what will be gt?
3 cosine t.
Yeah, this essentially is my gt, right? Okay, so will be, and what is A? A is pi. Okay. So e to the power minus pi s, Laplace transform of 3 cosine t. But before you do the transform, is this guy go to t plus pi first? Okay. Sine t plus pi. This will be 3 times 3 times cosine cosine minus sine sine, and one of them is going to be 0. This one is going to be 0. This one is going to be minus 1, minus 3 minus pi s cosine theta. I think that's correct. Is that correct, guys? Yes. I think that's is that correct? Yeah, I think so. Okay, I think it's correct.
Don't we still have to take the Laplace transform of it?
I cannot hear you.
Don't we still have to take the Laplace transform of our cosine?
Oh, yeah, yeah, sorry. Terrible. Okay. What do I have? Is it cosine? Yeah. Yes. Okay. Thank you so much. Minus 3. Laplace transform of cosine is going to be s over s squared plus 1. Okay, I think that's it. I think that's good now. Okay. So, what is this other side? This other side is s plus 1 ys minus 5, right? It's okay? So I end up with ys s plus 1 is equal to 5 minus this guy. Okay. So ys will be 5 over s plus 1 minus 3 . This is s squared, sorry. Okay. I think we are good. 3 e to the power minus pi s over s plus 1 s squared plus 1. Okay. Are we okay up till here?
Yeah.
Okay. We need to take the inverse transform of this guy. Okay. We're going to have save this and then take the inverse transform. Sorry. Can I erase those?
Wait.
Yeah, yeah, okay. Sorry, I erased part of it already.
That's good. Just wait.
Yeah, yeah, I'm not erasing. I'm just copying this up. Okay. There's an S somewhere here. I think so. Okay, that's good. Yes. Is it okay?
Yeah.
So in order to continue, I have to partial fraction this guy. Okay, I have to partial fraction that guy. Can I just write down the partial fraction expansion without actually going through the actual process? Or do you insist me going through the actual process? I don't mind either way. We actually have kind of time. Do you guys care? Actually, it's this. If you actually go through, this is A, and then BS plus C, you actually end up with this. Okay? I am going to skip the actual partial fraction part, okay? I'm going to skip that part. And now, I end up with this, okay? I take the 2 out, 3 over 2, okay? Okay. And then I need to do inverse transform.
What
And then
happened to the e to the negative pi?
I'm terrible. Just terrible. Better?
Yeah. Thank you.
Okay. So YT inverse transform of this guy is 5 e to the power
Minus t.
negative t. Okay. E to the power negative t minus 3 over 2. Now I'm going to have to do Laplace transform of each of these separately. Let me just write it out like this. What is the easiest way to think about it? I am going to do the, maybe I can do them together. So, okay, let me use that formula. Okay, let me use that formula. The formula that we used earlier. Let's write down the formula there so that we can use it. Okay, the formula that we are going to use is this. It's not this, this is in the forward direction. The backward direction is this one. Okay, that's the formula we are going to use to tackle this part. What will be A? Over here, what is A?
Pi.
A equal to pi. Okay. A equal to pi. So A equal to pi. So I need the inverse transform, okay, of this whole thing, or this whole thing, okay, and after I do the inverse transform, I will put t replaced by t minus pi, okay, and then I will put down u t minus pi to multiply. Is it okay?
Yeah.
This is going to be 5 e to the power minus t minus 3 over 2. Now the Laplace transform of this guy here, what is this? Laplace transform of that guy here is negative sine t. Is it okay? Did they cancel? They cancel. Let me see whether they cancel. They look like they cancel that, unless I make a mistake. No, they don't cancel. I mess up. This first one is not sine. What is this? This is, I misread it. I thought this is s squared plus 1. This is just s plus 1.
Negative e to the negative t.
E to the negative t. Thank you so much. That's better. Okay. And then this guy, there's a sine term and a cosine term. Let me know if I make a mistake. Okay. Then the whole thing t to t minus 5, and then u t minus 5. This t need to be changed to t minus 5. Okay, and then here change to t minus 5. Here change to t minus 5. Is it okay? So this is essentially our answer, guys. Okay, but I'm going to show you a picture of the answer. How does this function look like? I'm going to wait a little bit before I erase some stuff to get some space. This is essentially our answer. Okay, in a compact form. Okay, in a compact form. I forgot this. Oh my god. I forgot this guy. Okay. This ut minus pi just is for this part, not for the beginning part. You can see that at the beginning part. So this term come into play only after time t. At the beginning is exponential decay. This is exponential decay. The charge in the capacitor is just draining down in an exponential way. Okay, and suddenly at time t equal to pi, you flip the switch, and it's driven by this AC battery. The AC battery will cause this behavior. Okay, cause this behavior. This behavior is essentially a combination of the original exponential decay, if this is continuing somewhat, and then together with this external sinusoid. I am going to are you guys okay up to here? It's a lot of stuff. I'm going to erase this part. Is it okay? Can I erase some stuff? I'm going to save this one at the end.
I think you're good.
I'm going to
Yeah, you're good.
Okay. I'm going to erase some of this stuff. Because I want to talk about the interpretation a little bit. this guy is kind of hiding a lot of things because it's in one compact form. To be able to understand it, you remember at the beginning we have this non-compact form, and then we write it in a compact form, so that we can do the Laplace transform and do all the solve the problem. But now we're going to kind of go backwards from this, writing this in the piecewise definition. Okay, so this guy is saying that at the beginning, this is what it's saying. It's saying that at the beginning, okay, for time before t equal to pi, what is this function? What is this function before t equal to pi? What does this function degenerate into at the beginning? This guy is zeroing this guy out. Can you guys see that? So this thing here is zeroing the whole thing out. So at the
So
beginning,
you're
we
just left
only
with
have
5e to the negative t.
yes, this is what happened at the beginning. And after that, we're going to take the whole thing. Okay? After that, we're going to take the whole thing, which means it's going to be 5e to the power minus t. Just copy the whole thing. Okay? Yeah. We can just copy the whole thing. Minus 3 over 2 minus e to the negative t minus pi plus cosine t minus pi plus sine t minus pi. Okay, this is what happened later. If you like, you can also simplify this too. Expand it out using the trig formula. Okay. How are we doing? I'm going to show you the picture of this guy. Okay. By sharing my desktop with you. But before that, you guys have questions? Okay. I'm gonna share the screen. You are seeing my screen, right?
Yeah.
So this is the picture of the function. At the beginning, you have this exponential decay, and then this is time pi, and then you start to get driven by this external function. Is it okay?
Yeah.
Okay, so I'm gonna unshare this. So I was just reading the chat. I mean, I don't understand. Hence, you say isn't the midterm or the middle term okay? Yeah, okay, so I understand now. Okay, so I'm basically done with this section, okay? I do have another example, okay? that I want to talk about, which will show you why this type of stuff is useful. But I haven't really prepared. I haven't prepared the example, so I can try to make up the example now. Okay, and you guys make sure that I don't make any mistake. Is it okay?
Yeah.
I am making up the example now. It's one of these problem with those mixing tank. Mixture column. Okay, you have this tank. I'm making the numbers up. Conceptually, I know what I want to do, but I haven't really prepared all the detailed numbers, so I'm making things up. How about this is 500 liter of stuff. Okay, salt solution. Okay, salt solution. And this is coming out here at let's say 10 liters per minute. Going in is also the same. Okay, 10 liters per minute going in. But there's a switch here. There's some kind of switch here. Okay, some kind of switch here. All right. This switch look like this. Look like this. So this through line there, you can shrink it around. The blue one, you flip it over, become the green one. So these are different paths. Okay, you have different paths here. So concentration. Let's say that one of the path. This is a valve then. Okay, this is a valve A. This is a valve B. Okay, it's a valve. Okay, so valve A going here. Let's say is concentration of 4 kilogram per liter. This other path will be, let's say, 8 kilogram per liter. Okay, you guys understand what I'm doing? So originally, you start out with valve A. All right. Start with valve A. I mean, so the mixture coming in with valve A open and B closed. Okay. At time T equal to, we'll just pick something. T equal to, let's say 5. Okay. At T equal time T equal to 5. We close A and open B. All right. And initial amount of salt, let's say, is 20 kilogram. Okay. And then we want to see what happened. Okay. we want to solve for yt, which is amount of salt in the tank at time t. You guys understand what we are trying to do? I actually will need to take a picture of this myself because we probably won't finish it today and we will need to continue later. So let me take a picture of this. Okay. Okay, I got it. Okay. So based on this, we're going to try to set this up and then try to solve something. How do we solve it up? Okay, so first the question is that 10 liters per minute coming in, 10 liters per minute going out. Is this level change? Does the level inside here change?
No.
It will never change. Now, what is the, so it's basically rate in minus rate out, right? So y prime, which is dy dt, should be equal to dy dt is going to be equal to this is the rate of change of amount of salt. Okay. So at the beginning, it's going to be at the beginning. Okay, it's equal to some function. Okay, some function, which is f of t minus this is the rate going in. Okay, we're going to figure out this rate. This f of t is going to be ugly because it's switching around. Rate going out is going to be what? Maybe I have ft times 10 then. Okay. This f of t represents the concentration. This is kind of the concentration. This is concentration. Times 10, concentration times the flow rate, minus going out the concentration will be y over what? What's the concentration going out? You're stirring this around. Are you guys following this? We did this stuff before, right?
Yeah, it's like the other mixing problem.
What? Say it again. I cannot
Similar
hear.
to the other mixing problems we've done.
Yeah, it's similar to the mixing problems. What is y0? What is y0 here?
20 kilograms.
20 kilograms. Now I have to write down what ft is. ft is actually equal to 4 at the beginning. It's equal to 8. Okay. So how do I write this in a compact form? Anybody? It's equal to 4 and then later on change to 8. Okay. Okay. Equal to 4 and then change to 8. So I need a function. I need this 4 times a certain function plus 8 times some other function. Okay. This function here, I mean, okay, let me just write it down and see whether you guys understand this, agree or not. If not, I will explain this more. 8 times u t minus 5, 1 minus u times t minus 5. I probably need to explain it. Last time I explained this type of stuff with a graph. It's difficult for you to see. And then when I explain it with a table, it seems to be easier. So I'm gonna do it with a table. Okay. So t is for t to be between 0 and 5. And then I want t to be bigger than 5. Okay? This function, there are 2 functions here. One is called g of t, one is h of t. Okay? So what do I want? I want h of t. This is the h of t. This is h of t. This is g of t. Okay? The h of t, I want it to be 0 here and 1 here. Do you guys agree with that?
Yes.
And the g of t, I want it to be 1 and over there, 0. So when t is between 0 and 5, I'm going to pick this up. This is 1, that one is 0, so I pick up the 4. T bigger than 5, I pick up the 8. Is it okay?
Yes.
And what is h of t? 0 at the beginning and 1 later. That is exactly ut minus 5. Okay, and this one is the opposite. So it's 1 minus ut minus 5. So you can see that here g of t is equal to 1 minus h of t, right? 1 minus this guy. 1 minus 0 is 1, 1 minus 1 is 0. Do you guys follow that?
Yeah, you can keep going, Professor.
Yeah. Yes?
Yeah.
Yes? Good. Okay. So now we have this set up now. I'm going to erase the table because I'm running out of space. Okay?
Wait. Okay.
Don't worry. We'll fix it. Okay? Let me know when you're ready then.
Okay, I'm good.
Good?
Mhm.
So here, my equation actually look like this now. dy dt equal to 4, 1 minus 0, t minus 5. Okay. Plus 8. Plus 8. Okay. U t minus 5. I'm going to erase this now. Four times this plus 8 times this. The whole thing multiplied by 10. Subtract. Subtract. Y over 5. Okay.
Isn't it y over 50?
Huh?
Isn't it y over 50, not y
Y
over
over
10?
50. Thank you. Y over 50. Okay. I probably can I probably want to simplify this a little bit. Okay. So for minus 4 of this plus 8 of that is 4 of this. I think I'm still good. Okay. Times 10 minus y over 50. So dy dt plus y over 50 is equal to, why do I do 4 times 10 is 40? 1 plus u t minus 1. Are we still okay?
Yeah.
So this one will become sys minus what? Minus initially how much? Forgot. What's the initial condition? I wrote it down already. 20, right? 20 kilogram. You guys follow this?
Yeah.
This is this.
Yeah.
Laplace transform of the first term. Laplace transform of the second term. Okay. It's equal to Laplace transform of this. 40. What's the Laplace transform of 1? Laplace transform of 1 is 1 over s. And then the Laplace transform of just this guy, ut minus 5. Okay, ut minus 5. Now in this case, Laplace transform of ut minus 5. So my function, my gt here, this g of t, okay, g of t is equal to 1. Okay, so you just put this in. And what's a? What is a? A equal to
5.
A equal to 5. A equal to 5. Okay, so this is just e to the power minus 5s. Okay, Laplace transform of 1 is a constant, and then when you replace by t to t minus a, it doesn't change the 1. So this guy is just 1 over s. Okay. I also need to take pictures of this because I need to take picture of this also. Okay. Let me take a picture of this. Next time, we are not going to be able to finish this one anyway. So next time we are going to do the inverse transform of this. Okay, to finish up this problem. Okay, but you can do your homework. Okay, homework is still on Tuesday. We already talked about everything that you know that you need to know in order to do the homework. But I'm not going to hurry through this because I have to move terms around and then do the inverse transform. Is it okay?
Yeah.
We will continue this with this. Oh, I have a record of this. So, anything you want to talk about? Anything else? Okay, I will have a good weekend. I'll see you guys on Tuesday then. Okay.
Thank you,
Thanks,
Tom.
Professor. You do the same.
Thank you, Professor.
Okay, you're welcome.
Wait, quick question. You said that our next exam is which date in particular?
What?
Our next exam is which date in particular?
The next exam is I don't know, whatever you say in the syllabus. I have to see.
5:19 at 11:10 a.m. to 1:40 p.m.
Okay. Whatever Jose just said, I think is correct. You can reading it from the syllabus, right?
From the syllabus, yeah.
Okay. Thank you.
Is that our final?
Yeah, that's final. Yeah. I already talked about it last time. The final is not going to be web assigned anymore. It's going to be submission through Canvas.
So we still have another exam and then the final, or our
No,
next
no,
exam?
no, no, no. The next one is the final.
Oh, okay.
Okay.
The next one is the final.
There's nothing in between. Okay.
You'll be putting up the study guide soon, right, Professor?
I can post it this weekend.
Oh yeah, that'll be great. Thank you.
You said you would clear that one. I think that's what you mentioned last time.
Thank you,
Okay.
Professor. Bye.
Bye.
Thank you.
Bye.